Okay, hi guys, happy Monday. Today we're going to talk a little bit about solving logarithmic equations. This is the end of section 5.5. We're going to learn two different methods, but we're just going to talk about the first one today in this video, and then the video that I post on Wednesday will go over method 2 for you. So for this first method, this one is really very straightforward. And it is that if you take a look at a logarithmic equation and you have logarithms on both sides of the equation and they both have the same base, then you can drop the logarithm on both sides and just set the arguments or the pieces that are in parentheses equal to each other. So this is method 1. We're going to come back to this reminder up here once we get a little bit further on. So let's just go ahead and get started. So for this first example, we do have logarithms on both sides for letter A, and the base is 3 on both sides. That will always be the case for any problem that I give you. I wouldn't give you one that had two different bases, but just know that the formula only works if your bases are the same. So because the logarithms are the same on both sides, I can take this argument, which is 5x minus 1, and set it equal to this argument, which is x plus 7. So I have 5x minus 1 equals x plus 7. And then from there, you can just go ahead and solve that equation just like you normally would. So I'm going to move my x over here, my 1 over here. That gives me 4x equals 8 and x equals 2. So I'm in good shape there. For the second problem, letter B, you see that your base is 8 on both sides, and you do have a logarithm on both sides. So using this first method from up top there, we're allowed to set these two arguments equal to one another and drop the logarithm. So we have negative 5x equals 4x plus 9. Again, very straightforward. Let's move that 4x over to the left-hand side. That gives us negative 9x equals 9. And x equals negative 1. Again, very straightforward as long as you have those logarithms the same on both sides. Let's take a look at the next two, C and D. So here we have log base 7 on both sides. So we're allowed to drop those logarithms. So we have 2x minus 1 equals x plus 5. Then from there, it's just a matter of moving your variables on one side, your constants on another. So we move our x over here, 2x minus x is x, and then we add 1 to both sides, and we get x equals 6. The next one, we have log base 14 on both sides. So we can drop those and set these arguments equal to one another. That gives us 5 minus 3x equals 6 minus 4x. Again, we're going to move our x's over here and our whole numbers over here. So negative 3x plus 4x is x, and 6 minus 5 is 1. Okay, those are the really easy ones that are linear. You don't have any quadratics or anything in there. These last couple are going to be a little bit more complex because we'll have quadratics that we need to deal with. So in this next one, we have log base 11 on both sides. So we're allowed to take this 3 plus x squared and set it equal to 2x squared minus 2x. So with the quadratics, you're going to want to put everything on one side and have a 0 on the other side so that we can do some factoring or reverse foiling, as you may want to think of it, and solve. So we're going to move the x squared over and the 3 over so that we have a 0 on the left-hand side. So we're going to have 2x squared minus x squared. That gets us to x squared. Then we have a minus 2x there and a minus 3. So here we're doing factoring. We need factors of 3 that are going to get us to a negative 2. We know we're going to use 3 and 1. So we're going to use x minus 3 and x plus 1. Once we do that, we can then take each of these pieces and set them equal to 0. So we have x minus 3 equals 0 and x plus 1 equals 0. This gives us x equals 3, and this gives us x equals negative 1. So we want to make sure that both of those answers are okay. So that's where this piece that I had written up here is a little reminder for you, that you need to make sure that whatever is sitting next to the logarithm, once you put your answer in there, this value must be greater than 0. So whatever you get in here can't be negative, can't be 0. So let's take a look at that down here in this problem that we just finished. So in other words, I want to take a look at 3 plus x squared and 2x squared minus 2x, substituting in these x's that I have down here. So if I put a 3 in here, 3 squared is 9 plus 3 is 12. That's greater than or equal to 0. That's fine. Over here as well, 2 times 3 is 6. 2 times 3 squared is 18. 18 minus 6 is also 12. So we're okay there too. So this answer is fine. For this one, with x being negative 1, you put your negative 1 in there. Negative 1 squared is 1. 3 plus 1 is 4. 4 is greater than 0, so we're fine there. Same thing's going to happen over here. Negative 2 times negative 1 is a plus 2 on the tail end. Negative 1 squared times 2 is 2. 2 plus 2 is 4, so we're okay there as well. So you do have to be aware of that when you're solving these problems, and it is these pieces that are in the parentheses that you have to check once you get your values for x. So make sure these are greater than 0 when you substitute your x's in. Okay, so let's look at the next one. It's log base 8. We're going to go ahead and set 4x squared plus x equal to 12 plus 3x squared. Again, we have an x squared and an x, so that's telling us we need to get everything onto one side and 0 on the other. So 4x squared minus 3x squared is x squared. My plus x is going to stay, and I'm going to move the 12 over. So here I'm thinking about factoring, which you may think about as reverse FOILing. We need factors of 12 that are going to get us to 1. Those numbers are going to be 3 and 4. So we're going to do x plus 4, x minus 3 equals 0. Last step, we have to set those each equal to 0 and solve. This gives us a negative 4, and the other one is going to give us a positive 3. So those are our two possible answers. Last thing, like we did over here, we substitute these values in and make sure that we do not have anything less than 0 in here and in here. And for us, both of these answers are going to be fine. Okay, just two more. So we're down at the tail end here now with these last two problems. I may need another piece of paper, but I'll try and make it work. So we have the same base on the left and the right. So I'm just going to set 3p equal to 5p plus 8. Whenever I do that, I'm now going to move this over to the left because it's linear. I don't need everything on one side equal to 0. This is negative 2p equals 8, which gives me p equals negative 4. Okay? Which seems like it might be fine. However, when you go up here and take a look at these two, remember these must be greater than 0. If I put a negative 4 right here, 3 times negative 4 is negative 12. So because 3 times negative 4 equals negative 12, and that's less than 0, that means p equals negative 4 does not work. It's not a solution. You don't even have to check this one over here. If it fails on one of them, it's a problem. So your answer for this one is just no solution. It's not going to work at all. We thought we found an answer, but when you check it and see that the value that ends up in here is less than 0, that's a problem. One last problem for you. Base is the same, left and the right. We're going to set those arguments equal to one another. Negative 2m minus 1 and m squared minus 25. Here you have an m squared and an m, so we're going to move everything over to the right and set it equal to 0. So that's m squared plus 2m minus 24. And here we're going to do some reverse FOILing. Factors of 24 that are going to get us to 2. That's going to be 6 and 4, because 6 times 4 is 24, and 6 minus 4 is 2. So we need a plus 6 and a minus 4. When we set those equal to 0, we get a negative 6 that we can test, and we also get a 4 that we can test. However, when we do this, when we put this 4 up in here, negative 2 times 4 is negative 8 minus 1 is negative 9. This one is a problem. This one does not work because when I put it in here, I get something that's less than 0. This one, however, is going to work. Negative 2 times negative 6 is a positive 12, minus 1 is 11, which is still greater than 0. Negative 6 squared is 36, minus 25 gives us 9, which is still a positive value. So our answer here is m equals negative 6 only, because this one does not work. So this one has a solution, but it only has one solution, not two. Okay, so that again is our first method for solving logarithmics. This again is section 5.5 up. I have these posted for you on your module for chapter 5. And there are two worksheets for this week. The first one is on this method, and the second one is on the method for Wednesday's video. And there will be a quick quiz on Friday this week as well. So both of these worksheets and their answer keys are already posted. They're just for completion purposes to make sure that you understand the content before you try your quiz on Friday. I'll be posting another video on Wednesday, and I will also have office hours at 1 p.m. on Wednesday should you need any help. Okay guys, I hope you are all well. Take care, and I will talk to you on Wednesday. See ya.